Good morning, students. After real numbers, today we will start the chapter of polynomials. That is chapter 2 of NCERT book, and the first chapter 2.1 we will see, which is actually the geometrical representation of the zeros of the polynomial. Before going into details, let me tell you that this chapter of polynomial is not a new thing for you. In your junior class, in standard 9 also, you have learnt the polynomial. So, let me refresh your memory once again and let me give you the basic concepts of polynomial, what a polynomial is. In 7 and 8, in class 7 and 8, you have learned algebraic expression. So the polynomial is also an algebraic expression. It is a special type of algebraic expression. Now, what is polynomial? I have written on the board, any algebraic expression. See, any algebraic expression in the form of Px equals to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus plus an x to the power n is called a polynomial in x. The variable here is x. It is a polynomial in x variable of degree n. Highest power, smallest one is 0, 1, 2, 3, like that. The height, it is suppose that all the powers are arranged in ascending order of magnitude, and in that case the highest power happens to be n. So it will be called that it is a polynomial in x of degree n. If and only if it will be called polynomial of degree n, if and only if the coefficients of the variable x, this is x0, x1, x to the power 2, x cube, x to the power n, and its coefficient is a1, a0, a1, a2, a3. These are the coefficients of the variable x. If a0, a1, a2, a3, an are real numbers, most important thing, the coefficient must be a real number, and the powers of the variable x are non-negative integers. Non-negative integers. What is the meaning of non-negative integers? Non-negative, as I told you earlier, non-negative means either 0 or positive. Now see the powers of x, powers of the variable x, 0, 1, 2, 3, 4, n. So all the powers of the variable can either be 0 or positive integer. In no case the power can be in fraction or negative. The powers of x must not be negative, it must not be in fraction. If it happens, then this polynomial will be termed as a polynomial in x of degree n, one more condition, and an not equal to 0. That means the coefficient of the highest power of the variable should not be equal to 0. So this is the basic definition of the polynomial, dear students. You must go through it. You must try to understand each and every word that I have written in this definition. Now, what are the types of polynomial that we will discuss now? Polynomials can be divided, I know, in your earlier classes, you are knowing, you have understood some of the properties of the polynomial. Once again, we will recap all the things. Types of polynomial. Types of polynomial. On the basis of on the basis of terms, and second one on the basis of degree. On the basis of term, first one is monomial, second one is binomial, third one is trinomial, and the fourth one is quadrunomial. Quadrunomial, and like this it will go on. What is the meaning of monomial? Monomial means a polynomial which is having only one terms. If I am writing 2x, single term it is 2x. If I am writing 7x to the power 5, again one term. I am writing simply x, it is also monomial. So these are the examples of monomial. Here the variable is x. Now we are coming to the binomial. Binomial, there must be two terms. How we will define the terms? The terms will be separated either plus or minus sign. Suppose 2x plus 5. Yes, two terms are there and they are connected with plus sign. Suppose 5x cube minus 2x square. Yes, binomial it is because there are two terms. Similarly, x to the power 7 minus x square, it is also binomial. So examples of binomials means binomials will contain two terms and these two terms must be separated either plus or minus signs. Trinomial, three terms will be there. 2x square plus 5x plus 9 can be one of the example. 2x square first term, 5x is the second term, 9 is the third term. This is a trinomial. In this way, you can write x to the power 7 plus x to the power 2 minus x. This is also a trinomial. There must be three terms and they will be separated either plus or minus signs. And quadrunomial, similarly, there will be four terms, x to the power 17 minus x to the power 11 minus 5 x to the power 9 plus 6. This is an example of the quadrunomial. In this way, you can go for polynomial having 5 terms, 6 terms, 7 terms and n terms. This is on the basis of the terms. Now you see on the basis of degree. On the basis of the degree, the first one is the linear polynomial. Linear, degree 1. First degree polynomial is called linear polynomial. Our example will be 2x or 3x plus 11. 2x is a linear polynomial. How? Because what is the power of the variable? Variable x's power is 1. Here it is a linear. What is the power of x? X is here, it is 1. What is the power of x over here? It is x to the power 0. So in case of a linear polynomial, the highest power of the variable must be 1. Though this is also it is a linear polynomial. This one is also a linear polynomial as the highest power happens to be 1. Now second one is the quadratic polynomial. Quadratic polynomial. Degree 2. It will have 2 degree. That is, any second degree polynomial will be termed as the quadratic polynomial. Let me give you the examples. The examples are 3x square plus 3x square. Enough. 3x square is an example of the quadratic polynomial. We can write 3x square minus 7x. This is also a quadratic polynomial because the highest power happens to be 2. And this one is 7x square minus 5x plus 11, quadratic trinomial. You see, There we have given 3 examples of the quadratic polynomial. And what we are finding, that in case of quadratic polynomial, there can be 1 term, there can be 2 terms, there can be 3 terms. So the maximum number of terms that a quadratic polynomial can have is 3. 3 is the maximum number of terms that a quadratic polynomial can have, but not necessarily. This is also a quadratic polynomial having 1 term. So this is quadratic monomial, this is quadratic binomial, this is quadratic trinomial. In case of the linear polynomial, degree 1, what we are finding? Linear monomial, linear binomial. So if it is asked that what is the maximum number of terms that a linear polynomial can have? 2. Minimum number of terms? 1. Third one is the cubic polynomial. See, cubic polynomial. As the name suggests, its degree will be 3. Degree 3. Suppose I am writing 7x cube. Cubic monomial, 1 term, cubic monomial. I am writing 7x cube minus 5x square, cubic binomial. Then 14x cube minus 11x square plus 13, cubic trinomial. And the last one is 15x cube minus 12x square plus 11x minus 18, cubic quadrumonial. Why cubic? Because highest power of the variable happens to be 3. Here the highest power in this case 3, highest power 3, highest power in this trinomial is also 3, in quadrumonial is also 3. So this is linear polynomial, quadratic polynomial, cubic polynomial. And then the 4th power, that is known as the biquadratic polynomial. The 4th one is known as biquadratic polynomial. It is also known polynomial. It is also known as quartic polynomial. So biquadratic polynomial and quartic polynomial are the same. Now it will have maximum number of terms that a biquadratic polynomial can have is 5. In the same way, highest topmost power must be 4. Then it can be binomial, trinomial, quadrumonial, polynomial having 5 terms, and like this it will go. Apart from these 4 categories, you must remember that on the basis of degree, another polynomial is known as constant polynomial. Constant polynomial. Any constant, its degree 0. Write any constant number, suppose 7. It's a constant polynomial. Because 7 can be written as 7 into x to the power 0. You are writing 11, minus 11. Yes, it is a constant polynomial. You can write it minus 11 x to the power 0. So what we are finding, the degree of a constant polynomial is 0. And the last one is 0 polynomial. 0 polynomial. Degree not defined. We don't know what is the example. 0. 0 is, students, after seeing the various types of polynomial on the basis of terms as well as on the basis of the degree, we will see what do we understand by the zeros of a polynomial. Zeros of a polynomial px and its geometrical meaning. Now, let px 4x minus say 20. Px is a polynomial which is equal to 4x minus 20. Px means polynomial in x. You don't confuse it that it is p into x. It is a polynomial in x and it is 4x minus 20. Clearly, it is a first degree polynomial, so it is a linear polynomial. Now, what is zeros of a polynomial px? Zeros of a 0 or zeros, let me write it. 0, you will also write it down. 0 or zeros of a polynomial is that value or values of the variable for which the polynomial becomes 0. For which the polynomial becomes 0. 0 or zeros of a polynomial is that value of the value or values of a variable, that value, single value or values of a variable for which the polynomial becomes 0. Suppose our polynomial is px is equal to 4x minus 20, which is a linear polynomial. For finding the zeros, we equate the polynomial with 0 and solve the equation thus obtained for the variable. What I mean to say, in order to find out the 0 or zeros of the polynomial, we will simply equate the polynomial with 0 and then the polynomial will be converted into an equation and then we will solve for the variable. So in this question, what we will do? We will write px equals to 0, that is 4x minus 20 equals to 0. 4x is equal to 20 and x equals to 5. So 5 is a 0 of 4x minus 20. So in order to find the 0 or a polynomial can have more than 0. Remember, the 0 depends on the degree of the polynomial. It is a first degree. So maximum number of 0 that this polynomial can have is 1 and that 0 is 5. In case of a second degree polynomial, the maximum number of 0 that a second degree polynomial can have is 2. Say, let px is equal to 16. Quadratic polynomial it is. Now, the question says, find out the zeros. Let it be px is equal to x square minus 16. A quadratic polynomial it is. And you are required to find out the zeros of this quadratic polynomial. What we will do? We will do px equals to 0. That is x square minus 16 equals to 0. X squared equals to 16, x equals to plus minus 4. So what we are finding here, there are two zeros. The two zeros are, one is 4 and minus 4. So since it is a quadratic polynomial, the maximum number of 0 that a quadratic polynomial can have is 2. The maximum number of 0 that a linear polynomial can have will be 1. The maximum number of 0 that a cubic polynomial will have is 3. So this is the basic thing that you have to know. Now we will see the geometrical meaning. Now px means polynomial in x. 4x minus 20. We can suppose this px is equal to y. Px can be supposed as y is equal to 4x minus 20. Now see, y stands for the polynomial in x. Now if you plot this y is equal to 4x minus 20 on the graph, if you plot this y is equal to 4x minus 20 or px is equal to 4x minus 20 on the graph, this is y-axis, this is x-axis. So the 0, which is 5, you will find we know how to plot it on the graph. So 4x minus 20 will be plotted on the graph. In that case, that it will be first thing, it will be a straight line. Why it will be a straight line, can you say? Because the degree straight line, the reason is degree is 1. Degree is 1. Any first degree equation when plotted on the graph, it will give us a straight line. And this straight line will cut, if on plotting this straight line, you will plot it properly. And when you plot this, you will get a straight line like this. In standard 9, you have seen, you have learned how to plot a straight line. Y is equal to 4x minus 20. And when it is plotted on the graph, it will cut the x-axis at a point where the value of x equals to 5. So simply the geometrical interpretation of the polynomial is, if the polynomial is plotted on the graph, the number of point of intersection with x-axis will tell us the 0. Suppose I am giving you another example, and after that 2.1 can be completed very easily. The geometrical interpretation says if that polynomial is plotted on the graph, then the number of points where it intersects x-axis are the number of zeros. What I mean to say, suppose this one is the xo x dash, yo y dash. Now suppose this is a line. This is a polynomial. This is a polynomial in Px. Linear polynomial. Now in how many points this polynomial is intersecting x-axis? Definitely at a single point. So how many zeros this polynomial Px is having? 1 0. Say the second example, xo x dash and yo y dash. See, this is a polynomial called Px. This is x-axis, this is y-axis. Now see, at how many points this graph line, this polynomial intersects x-axis? 1, 2, 3, 4. So what we are finding? 4 zeros. There are 4 zeros of this polynomial. Here it is 1 0 of the polynomial. 1 0, 4 zeros. Now see this one. This is the polynomial fx. In how many points it intersects x-axis? Students, see very carefully. There are 2 points at which the fx intersects x-axis. Therefore, how many zeros are there? Simply exactly 2 zeros are there. Now, I am drawing this one. xo x dash. Now this is fx. Fx is a polynomial. How many zeros are there? See, here fx is not intersecting the x-axis. We have nothing to do whether that fx is intersecting with y-axis or not. But simply, fx is not intersecting x-axis, so it has got no zeros. It has got no real zeros in fact. If I draw this polynomial is touching x-axis at a single point. So how many zeros are there? Definitely it will have only one zero. Now, if a polynomial is like this or like this, parabolic, U-shaped or inverted U-shaped, it will be a quadratic. This is a quadratic polynomial. This is also a quadratic polynomial. The standard form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. So standard form of a quadratic polynomial is ax square plus bx plus c is px is equal to ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. Now a very interesting thing here, if this value of a, it is not 0. If a is positive, a is greater than 0, then it is a quadratic polynomial. The quadratic polynomial will be U-shaped, parabolic and U-shaped. And if a is negative, smaller than 0, then the polynomial will have inverted U-shape. So it is U-shaped, both are parabolic, it is inverted U-shaped. Hope you have understood, dear students. Now see a few questions I will read out from this, and very easily you can solve by yourself. Simple thing is that you have to see at how many places the given polynomial is intersecting the x-axis, and that will give you the number of zeros of that polynomial. Only one question is there in exercise 2.1. 6 figures are given. In the first figure, you see you are having the NCERT book with you. Exercise 2.1, page 28. See the first graph. It is a straight line parallel to x-axis. What it means? It does not intersect x-axis. And if it does not intersect x-axis, you will say it will have no zero. It is having no zero at all. It is not having any zero. In the second figure, you see the graph goes like that, and that graph line is intersecting. That is the graph line of the polynomial. That graph line is intersecting x-axis at one point. So the number of zeros is 1. In the third one, you see, what about the third figure? In figure 3, the graph line is intersecting x-axis at 3 points, 1, 2, 3 points. So how many zeros are there? 3 zeros are there. In the fourth one, the graph line, if the graph is intersecting x-axis at 2 points, and so the number of zeros is 2. In the fifth figure, the graph line is intersecting x-axis at 1, 2, 3, 4 points. So the number of zeros is 4. In the last figure, sixth figure, the graph is intersecting at 1 and intersecting at 1 and touching x-axis at 2 more points, 1, 2, 3. Therefore, the number of zeros in figure 6 of question number 1 of exercise 2.1, number of zeros is 3. I hope you can easily identify the number of zeros by seeing that in how many points the graph line is intersecting x-axis. If it is intersecting at 1 point, 1 zero, 2 points, 2 zeros, 3 points, 3 zeros, and like that. So dear students, we have discussed, I have tried to give you an idea of the polynomials and the graphical, geometrical meaning of a polynomial, zeros of a polynomial. I try to explain. Zeros of a polynomial is that value or values of a variable of a polynomial for which the polynomial becomes 0, and by geometrically we can say the number of points where the polynomial graph intersects x-axis. So that's all for today. In the next class we will start with the relationship between the zeros and coefficients of a polynomial. Till then, goodbye students.